So finding theta when theta is between 0 and 2 pi. We're going to look at a few examples of this. So the first one, the sine of theta is equal to radical 3 over 2. I'm going to try on this first one to relate it more to our unit circle. So if we look at our unit circle, remember sine we know is y over r. So I want you to kind of look at the unit circle here. On the unit circle, where is our y value radical 3 over 2? Well, there's 4 places where y is radical 3 over 2. We know it's radical 3 over 2 here at 60. We know it's radical 3 over 2 at 120. We know it's radical 3 over 2 at 240. But actually it's negative here. And then we also know at 300, y is negative radical 3 over 2. So what we have to decide here is, since we're trying to find theta, we have to determine, whereabouts is that going to be, or where, what's theta going to be in terms of those 4 choices. Well, with it being positive, we know that, on our quadrants, where is sine positive? Well, we know sine is positive in the first quadrant. We know sine is positive in the second quadrant. So that's going to help us to determine that the sine of theta, again, if we're just utilizing the unit circle here, it's going to happen at 60 degrees or at pi thirds, and it's going to happen at 120, which is 2 pi thirds. So our theta value, just using the unit circle, pi thirds and 2 pi thirds. Again, that's 60 and 120. Everybody follow that? Now, I'm also going to take you through that process just like we did yesterday. We know it's in the first quadrant, and we know it's in the second quadrant. If you're not wanting to use the unit circle, go ahead and fill in your values. We know that, if we're in the first quadrant, radical 3 over 2, sine is opposite over hypotenuse. Well, the opposite would be radical 3. This would be 2. This would have to be 1. If we're using our triangle, the side opposite the radical 3 has to be the 60. And again, this right here would also have to be 60. So that helps us to determine our theta value there also. So we can still be at 60. We go around to here, that's going to put you at 120. Okay, let's look at another one. Let's do the cosine theta is equal to 0. Well, again, the thing you want to remember here for cosine is, we're not going to be in any of our quadrants and get 0. So we know this is going to be one of our quadrantals. Well, where is cosine going to be 0? Well, we know cosine is the same as x over r. So what we're looking for is, where is x going to be 0 on our unit circle? So as we look at this, let's again go back to our unit circle. Notice as I look at my quadrantals, well, x is going to be 0 at 90, and x is going to also be 0, down here at 270. So on this one, there's not really a triangle to be drawn. You might just plot your quadrantals here and think about, well, here at this point, I'm at 1, 0. Here I'm at 0, 1. Here I'm at -1, 0. And here I'm at 0, -1. Well, my theta then is going to be 90, which we know is pi halves, and 270, which is going to be 3 pi halves. Again, 90 and 270. Okay, I'm going to go ahead and go through this one. So cotangent theta equals -1. The way I would think of this is think about if cotangent theta is -1, that tells me that tangent theta is also -1. So when I do the reciprocal, so when I'm thinking about my, where is tangent going to be negative? Remember, all students think college. Well, tangent's going to be positive in the first and the third, so it's going to be negative in the second and the fourth. Now, tangent we know is opposite over adjacent, so opposite over adjacent is going to be 1, -1, and then here would be your radical 2. Same thing here, -1. That's actually going to be +1 and radical 2. So that tells me in this one, what kind of triangle do I have? It tells me that I've got a 45, 45, 90 based on my ratios. So as I'm going around here, 90 plus another 45, that's going to put me at 135 in terms of degrees, and that's going to put me at 3 pi fourths if I'm doing radians. If I go all the way around, 270 and another 45, that's going to put me at 315, which 315 is going to put me at 7 pi fourths. So my two theta is 3 pi fourths and 7 pi fourths on that one. Okay, example 4, we've got secant theta equals 2 radical 3 over 3. So for this one, what I would consider, first of all, we know the reciprocal function is cosine, and cosine theta is going to be 3 over 2 radical 3. I don't want to leave that radical in the bottom to help me when I'm setting up my triangle here. So if I multiply the top and the bottom by radical 3, that gives me 3 radical 3 over 6, which again simplifies to be radical 3 over 2. So my cosine theta that I'm using is radical 3 over 2. If I think about which quadrant I'm going to be in here, again, my little saying, all students think college. Cosine we know is going to be positive in the first quadrant, and we know it's going to be positive in the fourth quadrant. Now, cosine, as we know, cosine is adjacent over hypotenuse. So if I think about it in those terms, adjacent is going to be the radical 3, and the hypotenuse is going to be 2, which makes this a 1. So this tells me that I've got a 30, 60, 90 triangle. And again, I can fill this in. So in terms of finding theta, one of them is going to be 30, which we know 30 is pi 6. And if I go all the way around here, that's going to put me degree-wise at 330 degrees, which is 11 pi 6. So in terms of finding theta for the secant of 2 radical 3 over 3, we're going to be at pi 6 and 11 pi 6.